Welcome back to our prerequisite chapter. This is number 3, which is systems. A system is two or more equations that relate to each other, and the solution of a system is the point of intersection of those lines. There are a couple of methods that you could solve systems of equations by. That's graphing. Typically you want to use this when both equations are in slope-intercept form. There's substitution. We use this one when one of the equations is a lonely variable, when one of the equations is solved for or has a coefficient of 1. And then there's elimination. This is the most typically used one, and that's when the variables and the numbers line up. Okay, so let's see each of these methods in action. First, let's do graphing. Notice these are both in slope-intercept form. We graph the first one. We start at -2 on the y-axis, and then we go with a slope of -1. The other equation starts at 1 on the y-axis and has a slope of -1 as well. So it looks like this. Notice that the slopes are exactly the same between the equation. That means these lines are parallel, meaning they will never touch. Therefore, the answer to this one is no solution, because they will never intersect. Okay, let's look at substitution. Here, see that one of the equations, the y is already solved for. That makes it lonely. That makes this easier to substitute. And what we're going to substitute is, we know that y is -5x plus 3. So instead of y in the top equation, we're going to put -5x plus 3. So I substitute by, instead of writing y, I put parentheses, and then I substitute in my value, which is -5x plus 3. We're going to distribute, which gives us -6x plus 40x minus 24 equals -24. Combine like terms, we get 34x. Add 24 to both sides, and we get 0. Therefore, x equals 0. Now that we have one of our answers, we substitute back into one of the equations, the original equations, to find what y is. I'm going to use the second equation because it's already solved for y and it makes it easier to substitute. So do -5 times 0 plus 3, which is 3. To write this as an answer as a coordinate point, remember it goes x comma y, so this is 0 comma 3. Okay, our next method is elimination. Notice that the x's line up, the y's line up, and the constants line up. But here, they can't add or subtract the two equations and eliminate anything immediately. So what we can do is we can multiply one of the equations by a number in order for them to eliminate. This one, the second equation, I'm going to multiply by 2 to create the x being 18 as well. So I'm going to multiply by, and I put a -2 there because it's just making me remember that I am going to subtract. But I'm going to go ahead and just multiply by 2 immediately, and I get -18x plus 12 equals -12. And here I'm going to remember, I'm going to subtract these two equations. -18x minus a -18x becomes 0. We wanted that to cancel. Then 12y minus 12y, that cancels as well, so we have 0 on the left side of the equal sign. On the right side of the equal sign, -12 minus a -12 is also 0. So what we got was 0 equals 0. And that's a true statement, therefore this answer is infinitely many solutions. Okay, so those are the 3 different methods. Now let's look at systems in a word problem, in a real life word problem. All right, we're talking about two people planting daylilies and geraniums. So those are my variables I'm going to use. D is daylilies, G is geraniums. Okay, so Shanice spent $208 on 13 daylilies and 13 geraniums. So I'm going to do 13D plus 13G equals 208. That's my first equation. Daryl spent $72 on 8 daylilies and 1 geranium, so that's 8D plus 1G equals 72. Since they line up perfectly, I'm going to use elimination, and I'm going to multiply the bottom equation by 13 to get the G's to match up. So the top equation stays the same. Multiply the bottom by 13, I get 104D plus 13G equals 936. And I'm going to subtract in order to eliminate the 13G. When I subtract, I get -91D equals -728. Divide by -1, and I get that D equals 8. I'm going to substitute that back into one of the original equations. I'm going to choose the second equation just because the G, it's a 1G, so I'm going to find G quicker. So we do 8 times 8. Plus 1G equals 72, subtract the 64, which is 8 times 8, and we find that G is 8. So the idea here is that The daylilies were $8 and the geraniums were $8. Okay, the final type of systems I want to talk about is system of inequalities. It's the same as graphing a system of equations, except this time we're shading. Any point inside the double shaded area or that is on one of the solid lines will be a solution. It cannot be on a dashed line, however, and it cannot be any of the single shaded or the no shaded areas. So we're looking for double shaded area and solid lines. Okay, so here's the inequalities. We have y is less than or equal to negative 2x plus 3 and y is less than x minus 3. Right, the top equation we start at 3 on the y-axis and we go down 2 and right 1, so on and so forth, and we're going to shade below. On y is less than x minus 3, we're going to start at negative 3 on the y-axis, and then we're going to go up 1 and right 1. And then we're going to shade below as well. And what you find is that the double shaded area is at the very bottom center of the graph. Now this graph right here that I'm showing you only has one shaded area because I just went ahead and erased the single shaded areas. Okay, so our solution is inside the bottom triangle and on the solid line that touches that triangle. Okay, so those are the solutions to inequality, and make sure you always graph with those. All right, good luck on the practice and the application.